Hello everybody, this is Lukas Kautzsch talking to you from near the PTV headquarters in Karlsruhe, Germany, and welcome to the session about the new features in Vissim and Viswalk 2021. Well, this is a very special year for all of us. Everything changes, and due to the COVID-19 pandemic, the demand, for example, traffic demand has changed a lot in quantity, so there's much less public transport and demand and more private individual traffic, and there's also more active types of traffic like walking and bicycling. So this is quite a change for transport modeling as well. And well, the distancing rules also require to be modeled, of course, especially in the pedestrian simulation. So in Viswalk, also they have an effect on the capacity in public transport. But it's not only COVID-19 which changes a lot. There's also continuously changes in technology. On the one hand, on the streets, so autonomous vehicles are, well, coming maybe more slowly than some have said, but they are coming, and these changes, which are, well, brought by those to the overall traffic, are also of interest for the transportation modeling, of course. There's also technology changes in the IT industry, in the usage of software. So there's a big trend that software tends to be hosted more in the cloud, less on your local computer. And well, we are working on some things regarding that. And last but not least, there are new application areas for traffic simulation. So in addition to the traditional transportation planning, we have more and more requests from automotive OEMs, from automotive manufacturers who want to, for example, to test their new facilities in autonomous and connected vehicles with a simulation. And there are also providers of special modes of transportation. In addition to these future topics, we have also done a lot of kind of normal features. And that is because, well, transportation planning and traffic engineering is the application area where actually most of the current Vissim users are working in. And so we have added quite a lot of features which make working with Vissim even easier, better, and more efficient. And so there are quite a few new functions. For example, the attribute modifications. We have finally added a whole set of evaluations for parking and more evaluations for pedestrian simulation. Then there are new ways to control the behavior of pedestrians and of vehicles by new options in the behavior settings there. And there are also, last but not least, new additions to the network editor, which make it much easier to add certain things in the network. All those features will be shown in more detail in the next few minutes. The last feature I didn't mention yet is the video recording in 2D, maybe the most requested feature for a long time. I think it has a 2-digit or 3-digit number on our wish list, which contains, I think, currently about 2,000 items. So that's really an old one. So let's start with the new features which allow you to do things you couldn't do with Vissim before. The attribute modifications are a new network objects, and it's kind of a replacement for scripting. So with these new network objects, it's possible to have attributes modified of specific objects during a simulation run and in regular intervals, and the new value is defined by a formula. So in 2020, the last version, you had the scripts menu. Now you have the actions menu. The scripts menu items are still in there, but there are also attribute modifications. And now you have that new list of attribute modifications where you can define their parameters and where you can enter the formula. Also, well, there's the formula editor you might already know from the user-defined attributes. And well, in that list, you can define for each attribute modification when it is supposed to happen, for example, at the start of each time step. For all the time steps, you could also have only a certain time there. Well, in this case, it says it's only every second time step, but from simulation time 1 to the end in each second, every second time step. And then a certain attribute of this model, of a static 3D model, in this example, is set, and the attribute is state, which, well, in this kind of that barrier shows if it's open or closed or in between. It can have a value between 0 and 6, I believe. The num states attribute is also contains that value. And well, in this example, it says if the signal state is 1, so that is a user-defined attribute of the static 3D model, and if the signal is 1, so it is green, and the state is not open, which is the maximum number of states. So in this case, I believe it's 5 or 6. Then the state is increased by 1, so the barrier opens by 1 step, and this is done every 2 time steps. So well, if you have 10 time steps per second, every 0.2 simulation seconds. And also then, if the signal is not green and the barrier is not closed, it is closed by 1 step. Here you can see how that looks in with the formula editor. So if you double click in the list, you get this view.
Hello everyone, this is Adam. I'm going to take over from Lukas just for a minute, just to go over the attribute modifications in a little more detail. So how we're going to do that today is we are going to utilize one of the existing Vissim example files that currently relies on a COM script, and we're going to implement that COM-based functionality into the attribute modifications. To do that, I'm going to utilize the speed at signals example file that comes with Vissim. If you don't know where to find that, you can find that by going to Help, Examples, Open Training Directory. This one is under the Autonomous Vehicles folder, and Speed at Signals. So I already have it pulled up, so I'll go ahead and press play and just kind of walk you through a little bit of the functionality. So we have a single signalized intersection here. We have a number of different vehicle colors, you will notice. The black vehicles represent conventional vehicles, the yellow vehicles represent autonomous vehicles, and the red vehicles represent connected autonomous vehicles. And those are the ones that we're going to be focusing on today. What makes those vehicles connected is, as they are approaching the intersection, they are aware of when the signal head in front of them is going to turn red or green, and they can modify their speed in order to, in most cases, arrive at that traffic signal at the optimal time. So hopefully they don't have to stop. So you can see there at the bottom as those vehicles approach, it should be turning green, and they can go ahead and go off and return to their original speed. So that's the basics of how this works, and we can go ahead and dive right in. So let's first take a look at how the COM script is currently implemented. So if we go to the New Actions menu, and we'll find the event-based scripts, and as this opens, you'll see that there's a couple of COM scripts that run when the simulation starts, as well as every 5 time steps, but we don't need these anymore, so we can go ahead and delete them. Close that down. The next big piece, and where a lot of the kind of heavy lifting gets done, is within the user-defined attributes. So under base data, user-defined attributes, there are a number of user-defined attributes for both the vehicles and the signals. And this is where optimal speeds get calculated, where we know that how close we are to the vehicle is to the signal head, the time until the next screen. All those sorts of things are already done with these formulas, so just be aware if you want to know how this works under the hood. This is a good place to kind of start. So we're going to be utilizing all this information as it is. So I will go ahead and pull up our COM script. So this is the COM script that comes with the example file. This is about 130 lines in total, but we're going to be able to narrow this down to just 4 of these attribute modifications. Because with the attribute modifications, we also don't have to worry about a lot of things like this initiation, defining functions, changing tuples to lists, that sort of thing. So I will go ahead and put our Vissim window right next to it so we can go ahead and get started. Okay, so let's go ahead and get started in implementing this COM script now using the attribute modifications. So we go to the Actions menu, to Attribute Modifications, and we're going to pull up a dialog box when we click to add a new one. So here's the dialog box that comes up. You notice there's some information that's kind of similar to the COM interface where we define what period we want this to be in effect for, from time to time, also the period, which is how often we want this to run, how many time steps. If you put 1, it'll run every time step. The COM script was every 5 time steps, so we'll just go ahead with the same for this. Next, we want to choose the object type whose attribute we want to modify. In the case of this example, we're only going to be dealing with vehicles, so we want vehicles in network. Then we choose the attribute we want to modify. In this case, one of the first things that happens in this script is we record the connected vehicle's original speed. The reason we do that is when the connected vehicle modifies its speed to arrive at the signal at the right time, once it's past that signal, we want to be able to return it to its original speed. So we just want to make sure we record that for reference later. And that's done in the script. If we scroll down, basically what happens is this script is getting a list of all the vehicles. We're checking to only make sure we're working with the connected vehicles, which I'll show you how to implement. And then we're doing this condition here, which is we're checking to see if the original speed is none. Original desired speed is none. So we want to go to here, and we want to find that original desired speed. And this is a user-defined attribute. And thankfully, the names match up within the Python variable and the user-defined attribute. So we hit OK. And we're going to name these as well, just so we can keep track of what this is doing. Always a good idea. So we're going to say record original speed. So now here's where we define a filter. So this original desired speed will only get modified if this filter is true. So the first thing we want to do, as we talked about, is this conditional here where we're checking to see if we're dealing with a connected vehicle. So we can go ahead and choose this attribute selection. Now the connected vehicle is a function of what vehicle type it does in the simulation. So we're going to scroll down to these kind of relationships here and choose vehicle type. So we'll check the vehicle's vehicle type to see if receive signal information user-defined attribute is true. So we're just going to check equal to 1. And we're going to put parentheses here just to make sure that everything is well organized. And we're also going to need to check or do an AND function to see if the original desired speed has not been assigned yet. So with that, we can choose this again, and we'll see that any of these attributes that we've recently selected are going to be available in this Fast Access tab. So we can just select it and set it equal to 0. So at the end, this filter is just basically checking, is this a connected vehicle? And has its original desired speed attribute not been set yet? Is it equal to 0? And if that's the case, then here's where we can define what we want to assign to that original desired speed. In this case, it's very easy. All we want to assign it is the vehicle's current desired speed. We select that, hit OK, and we are done. That's our first attribute modification. Okay, so the next thing we want to take care of is once the vehicle passes the signal, we want to then return it to its original desired speed that we recorded in that first attribute modification. So in the script, that information is here, and basically the way we're checking to see if that connected vehicle has gone past the signal is there's this attribute distance to signal head, and when it's less than or equal to 0, then it is past the signal head. So because a lot of the information is going to be the same, I'm going to go ahead and duplicate that first attribute modification because we can reuse a lot of the information that we put in. So if I edit it and bring up the dialog box, this time though, we're not going to be setting the original desired speed, we're going to actually be setting the vehicle's desired speed, which again shows up in this fast access pane. And we'll go ahead and change the name. So we'll just call this reset speed, just to keep track of everything. Go ahead and delete this. Now for the filter, we still want to use this original filter that we used, and we're going to use it for each one of these attribute modifications, is checking to see if that is one of the connected vehicle types. So we can leave that where it is. But instead of now checking if the original desired speed was equal to 0, now we're checking if the distance to signal head is less than or equal to 0. So we can just go to the attribute selection, and if we start typing distance to signal head, it pops right up, and we say it's less than or equal to 0. So now our conditional filter is done, and now we want to select what we want to assign to the desired speed, and we're going to set it equal to the original desired speed. And with that, we've taken care of that. All right, with those first two attribute modifications done, we're about halfway there. So if we scroll down, you see the section here that says deciding about optimal speed. So we're checking, there's just a few conditional statements within here. If we scroll up, there's a couple of functions being called here. And if we scroll up into the functions, basically those functions are also just conditional statements as well, and just returns whichever the optimal speed is. So thankfully, that's also fairly easy to do within the attribute modifications. So I'm going to duplicate this again. We're going to edit. So for this one, we're still going to be changing that desired speed, so we can leave that as it is. So we are going to change the name, and the first thing we're going to do is this there is green ahead. So I can actually just copy that over and do the name, so we're consistent. And now we can change the conditional statement. As with all the others, we're going to keep this conditional about the connected vehicle, but we are going to modify this next one. And we're basically just going to copy this from the script. So check in this speed min for green end is greater than speed max for green start. So if Go here and just select those. So speed min. Speed min for green end. Okay. Is greater than speed max for green start. There is one additional condition we need to put in here that's not 100% obvious at the moment. So I'm just going to put it in here. We're also only going to want to do this for vehicles that have yet to pass the signal head. So I'm just going to add an additional condition in here that basically just says that distance to signal head is greater than 0. So just kind of know that that's something we need to do so this works right. So now we go here to what we actually want to assign it. And that's where these kind of additional conditions, basically it's saying, you know, is it better for me to keep going the speed I'm going now, or do I need to slow down? So it's just a matter really of implementing these kind of conditionals. Vissim provides that functionality also through an if function that is available within this functions here. If you select that, you're going to see a if function that's very similar to Excel if you ever use that. Now we're not going to take the time to work through all these conditions here. I kind of did that ahead of time. It's just basically all this logic can be implemented within a single nested if state, two if statements. So I'm just going to copy this in. You see this isn't too awfully difficult here. And with that, that piece is done. So this attribute modification we just did takes care of this if statement and this nested if statement here. Now we need to take care of this else statement. So there's not an else functionality here. So all I'm going to do is go in and duplicate this again. Hit edit. Most of this filter is going to stay the same. The only thing we're going to change is the filter that we originally brought over from this if statement. So we checked to see if the speed min for green end is greater than speed max for green start. So the opposite of greater is going to be less than or equal to. So all that, the rest of that can stay the same. And then we'll just change this to red ahead. So within this else statement, there's just kind of simple min function combined with a max function. These are also available in Vissim within the functions menu. So if we click that, you'll see there's a min and max available. So basically, again, I just kind of word for word just copied this over. Only difference is in the script, there's some variables that set these, and I'm just hard coding them here. So we just copy that over. Everything else should remain the same. We hit OK. And now we should be done with these 4 attribute modifications. We should have successfully replicated all the logic that goes on within this script. So we'll go ahead and maximize this, and we'll press play, and hopefully if everything worked out just fine, we'll see the red vehicles. The connected vehicles exhibit the same type of behavior, and it looks like we did a pretty good job.
And now we come to the feature which has been requested many times, and that is evaluations, result attributes for parking. So there are now new evaluations for parking spaces, parking lots, parking lot groups, and parking routing decisions. You can activate them as usual in the evaluation configuration with a time period and a time interval. And there are also some additional parking states in the attribute parking state of the vehicle now, new values. So, for example, the vehicle is blocked while it wants to leave the parking space. It's on the way back to its original route, or it didn't get a parking space assigned because there was no free one. The new attributes are aggregated values, and they are available, well, as I said, for parking spaces, for parking lots, and for parking lot groups. And these are, well, what you would think the number of currently parked vehicles, but also the number of vehicles which have started and have ended parking in this time interval, the total occupancy duration, the occupancy rate, so basically that's the percentage of time that the respective parking object was occupied, the average, maximum and minimum duration of parking per vehicle, and then the total parking fee collected during that time, and the time, how long the parking space was blocked, so how long vehicles have been blocked by other vehicles from leaving the parking space, and again the rate, so the percentage of that. For parking routing decisions, there's the total number of parking requests, so vehicles which passed the decision and were affected by it because of their vehicle type and because of the set percentage there. And then you have the number of accepted and declined parking requests, and the parking duration and parking rates are the input values, you know those, and the parking requests declined share is the share or the percentage of parking requests which have been declined there. So you can see what part of the passing vehicles could not get a parking space assigned. The parking evaluation, as I said, is available for per parking space, per parking lot, and per parking lot group. But what is a parking lot group? Well, it's basically just a set of a number of parking lots defined by the user. And we already had some thing called parking lot group, and that was for dynamic assignment. So now that group, which is only one per parking lot, is still available as the attribute which is named now destination group. But for the parking evaluation, a parking lot can belong to several groups. For example, in a large garage, you could have, say, all parking spaces on the second floor in one group, but also you could have all the parking spaces on multiple floors which are, say, close to the exit on the, say, western side of the garage. So you can have overlapping groups there. And in the parking lots list, you can also see these evaluation groups. That's the list of parking lot groups that the parking lot belongs to for purpose of evaluation. Well, and now what can you do with those values? Of course, you can see them in lists, and you can see them in the network if you use graphic parameters for parking lots. And in this one, you can decide if you want the coloring of parking lots depend on the values for the individual parking spaces, for the parking lots, or for the parking lot groups. And then you can select the attribute there. And well, here you can see an example where you have a coloring per parking space. So each individual parking space has the color depending on the occupancy rate over the current time interval in the current simulation run.
You can also visualize parking issues by setting the graphic parameters for vehicles to color by parking state. So in this video, you see the blue vehicles which are parking, the red ones which are blocked from leaving their parking space, the light blue ones which are driving to their parking space, and so on.
Thank you, Lucas. Today I'll be discussing the new parking evaluation feature in more detail. Over the past couple of years, there's been quite a bit of development regarding parking lots, with the new parking lot creator added in Vissim 2020, and now with the new parking evaluation features added in Vissim 2021. So the example I'll be going over today is for a waste management center. And in here, there are a few different areas within the model. For example, we have a staff parking down here at the bottom, a parking area for the larger trucks up here at the top, and then some areas for trash disposal and white goods recycling, and then a main recycling area down here at the bottom. As the vehicles enter the network, they will going to be assigned to one of these locations using the vehicle attribute decisions and formula-based routing. We also did a PTV Talks tooltips that used this particular example earlier this year, if you'd like to watch the recap on our website and just learn more about this particular model setup. So here's a look at our model. Again, we have many different sections within here. A lot of them are made up of parking lots made up of a single space, like here in the staff area and in the larger truck parking area. We also have some other parking areas, like in the recycling center, that are made up of one main parking lot with multiple different spaces. And then again, new within 2020 is where we can add these parking lot groups, which will group together these parking lots and then can be used within the evaluations. So in order to add in these groups, if you go up to lists and private transport and then parking lot groups, this will give you a list of all of those groups and will also allow you to add new ones. So you can just click this plus button and you can add some new groups within here. Once you have some groups added, you can then either double click on the parking lot and you'll see there's a new evaluation group section where you can go ahead and check off which groups you want this particular parking lot to be included in. Or you can also open up the parking lot list by right-clicking on the object and going to Show List. And here you'll see a new Evaluation Groups attribute, which will also allow you to select the parking groups from this dropdown. You can also click the Add button up here at the top, and again, that will just add another group to the list, which you can see over here in the parking lot group section. What's also really nice about this particular list is that you can select any of these parking lot groups, and that will show all of the associated parking lots here on the right-hand side within the child list. So for example, you can see here if we have the truck parking lot group selected, you'll see it includes all of these truck parking lots. And for this model, we've created a few parking lot groups, each for all of the different sections within this model. And then in order to turn on these evaluations, we'll just go up to the evaluation menu and choose configuration. And you'll see here we have a section for the parking lot groups, parking lots, parking routing decisions, and parking spaces. And if you choose collect data here, that will collect the evaluation results. You can also set the from, to time, and the interval. And I'll just go ahead and start the model. You'll see some of the staff vehicles will start parking here first for about the first 200 seconds, and then we'll get some additional vehicles going to the other areas soon after that. So you'll see here we've got some of the larger trucks going to the truck parking, and then we just have a variety of vehicles going to all of the different areas within this model. And as this is running, this is when we can start to look at some of those evaluations. So again, within the evaluation drop down, we can go to result list, and you'll see here we've got again the parking lot group results, parking lot results, and parking space results. And all of these have similar attributes that you can see for each of these 3 objects. And then there's also the parking routing decision results as well, which will just show you more information about the vehicles as they pass over that particular parking routing decision. So this will allow you to see the number of requests that came through, just the number of vehicles that drove over that particular parking routing decision, and the number of vehicles that had a request that was accepted and allowed them to park, and also the number of requests that were declined just because all of these spaces were full and there was nowhere for that vehicle to go. And in addition to all of these new evaluation results that have been added, we also have some additional graphic features that can be utilized. So first I'll just show you some of the vehicle coloring. So if you go to Vehicles and Network and just select the Edit Graphic Parameters button, you can change this drawing mode from Use Color Scheme to Color by Parking State. And you'll see here we have the legend turned on by just checking that box and then turning on the legend in the network editor. And you'll see here that vehicles now have a parking state associated with them. So if they're currently parked and dwelling, they'll be that dark blue. You'll see vehicles that are blocked and waiting to leave their space, just waiting for the traffic to clear. Those will show up in red. We also have some that are light blue that are actually just driving to that particular parking space. And then we also have some that are yellow, which are have left their parking space and are just going back to their main route. And so this can just be a really useful feature just to see the vehicles as they're in the network. You can just quickly see what their parking states are while watching the simulation run. And then in addition to the vehicle graphics, we also have graphics for the parking lots themselves. So if you choose the Edit Graphic Parameters on the parking lots, you can also change the drawing mode here to Use Color Scheme. And you can update this directly below it using that color scheme configuration. And so up at the top is where you can choose what that classification should be based on, if it should be based on the spaces, the parking lots, or the parking lot groups. And then you can also set that attribute that you're going to classify by color. And if you click the pencil, this is where you can choose any of those new attributes that have been added. Then these are very similar to the other evaluation features that already exist, where you can choose items like the current run, the current or last interval. You can also look at averages, or also information for just particular intervals as well. And let me just go ahead and turn off the vehicles here. And so this will just show us as the simulation is running what that occupancy rate is looking like for this current interval. And so this will just quickly allow you to see kind of those parking spaces showing up in pink or red that have a very high occupancy rate. And you'll see this is mostly showing up for the staff parking, where they are going to sit and dwell for the majority of the simulation, and also for that truck parking, which are also going to park and dwell for an extended period of time. And then you'll see in the green, particularly in the darker green, some of those parking spaces that have a very low occupancy rate. And so again, this is just another great tool that can be used just to graphically see how the parking spaces and lots and groups are performing. And with that, that will wrap up our look at the new parking lot evaluation feature. We hope that this will help you with all of your future parking models, and we hope you've enjoyed this section.
There are 2 additional result attributes which have been added to parking lots and also vehicle inputs, and these are latent demand and latent delay. Both have already been included in the network performance evaluation, and as result attributes for vehicle inputs and parking lots. They contain the same information, but separate per location. So if you open the new list vehicle input results or parking lot results, you can then see the latent demand and the latent delay per parking lot and per vehicle input and per time interval. For this walk, the pedestrian simulation, we have added a new evaluation which is called RSET, which is an abbreviation for Required Safe Egress Time. And the idea is that that RSET value shows up to which simulation second a grid cell of the pedestrian grid is occupied. So the planner knows that this location inside the building has to be outside of the concrete danger, say fire, smoke, and so on, until that time. So it's not to be confused with the time required for evacuation from that point, but the latest time when a pedestrian is at that location. And you can see that in this video, just a pedestrian walking there. On the left side, you see at the bottom the pedestrian grid, and now in the pedestrian grid cell evaluation, you have those values, and through a suitable color coding, you can show this. For the complete building with several floors, it looks like this. So you can see here easily that the stairs are, well, blocked for some longer time, whereas most of the rooms are free quite early. So, well, it's important to make sure that the stairs stay free of fire for the longest time there. Another attribute which has been added to the pedestrian and also to areas and to measurement areas is the information about the nearest neighbor. For the definition, this depends on the level of service distance in the network settings. So each other pedestrian who counts for the experience density, therefore the experience level of service, is also considered as nearest neighbor, and the pedestrian has always a relation to the nearest neighbor, so we can use that as indirect attributes, and also the distance. And you can use that, of course, in evaluations and also in the simulation. In this video, you can see how pedestrians walk, and the color code in this case through the graphic parameters depends on that distance to the nearest neighbor. And there's also an attribute modification in there which reduces the desired speed of the pedestrian depending on that distance to the nearest neighbor.
Welcome, I'm Levi Button, and I'm going to be talking about the nearest neighbor and experience density evaluations. Let's start with the nearest neighbor attribute addition to VisWalk 2021. If you go into the base data menu under network settings and pedestrian behavior, you'll be able to find this computation of experience level of service. What this does is this defines the radius from which the nearest neighbor calculation can be pulled. So let's take a look at what the nearest neighbor can do for us in VisWalk. So in this case, we see a subway platform. This happens to be Farragut West in downtown Washington, D.C. And what we see here is the eastbound platform and pedestrians alighting from the subway. Now, right now, we have the pedestrian color scheme set to look at the nearest neighbor distance. So we can identify how close the closest person is to each individual pedestrian. I've set up the color scheme in this case to represent yellow is 6 feet, which is about the minimum social distance you want to be currently. So we can identify where pedestrians are closer and farther away from other pedestrians within that threshold. This particular model was made pre-COVID, so obviously the walking behaviors are a bit closer than 6 feet. You'll notice some of the pedestrians are shown in black, and those are the pedestrians where the nearest pedestrian to them is farther away than our radius for computation. So in this case, we set our radius to 10 feet. And so anyone that is colored black in this case is farther than 10 feet away from the nearest pedestrian. Let's take a look at our density evaluations so we can learn more about this nearest neighbor attribute. Vissim currently calculates density in two different ways. First, we have the arithmetic density. This is where you take the square footage of an existing space and then count the number of pedestrians on it to calculate your density. However, we have an alternative calculation for density, which we call the experience density. And this is where you take each individual pedestrian and measure the space around them and then count the pedestrians within that space. This gives you a density around each pedestrian. And then we can aggregate that across all the pedestrians on an area to give us an experience density level in that area. Let's take a look at how experience density differs from density within a simulation. So we're back at Farragut West, and in this simulation, what we've done is we've activated the pedestrian grid cells evaluation. Within this evaluation, we've set each cell size to 1 foot. The smaller the cell size you have, the more data points there will be. This will have an impact on your simulation performance, but the smaller cell size you have, the more smooth your colorization will be. You can always increase the cell size to improve the performance of your simulation. In our network overlay, we're using the density graphic overlay, and what this does is this will color our grid cells based on the density, and we can see that here in the color scheme down in the legend. So it will it will subdivide each area into a 1 by 1 foot square. And then it will evaluate that square on its density. And here we can identify some hotspots, usually at obvious bottlenecks, such as stairs or security terminals, but also there are often hotspots around these 90-degree corners because people are condensing down to make the turn. So here, we can see that the experience density is a lot more yellow in a lot more spaces. And the reason for this is because pedestrians will avoid large groups, especially when in conflicting flow. And so therefore, they kind of get bumped out to these outer spaces. So while the arithmetic density is relatively low farther out here, we can see that a pedestrian's experience when walking through the space feels a lot higher. We can also see that these hotspots are a little bit more diffused, especially on these corners, where we see these really dark spots right around the corner. But when we move to experience density, we see that people aren't actually taking that hard cut. Some of them are going a little bit wider. And so we can see how the experience of this corner is a little bit more diffused than the arithmetic density would suggest. So now let's get into what is new in VisWalk 2021. And this is the duration attribute that we can add to some of our evaluations. So we can define those thresholds within our pedestrian grid cells for density, experience density, speed, velocity variance. But we also have now the ability to configure our color scheme to select this duration threshold. So how long has the density exceeded this threshold? So if we set our experience density threshold to roughly equate to about 6 feet of social distancing, we can then collect data on how long are people within 6 feet of each other. So here's just a quick conversion on how we came up with this threshold value. You take the social distances and you calculate the area of a circle around that with that radius. The area, which is in feet squared per pedestrian, you just invert it to create a density for pedestrians per square feet, and that gives us our threshold that we want to go with. So let's take a look at this new attribute within Vissim. So if we look at our density duration, we can see here that the darker the color is, the longer the flow has been above that, exceeded that threshold. So we can see the spaces where people are in continuous contact with each other, especially in these tight bottlenecks where we're seeing, if you only open up one egress gate, for example, we can see that people are in close proximity to each other, in this case, exceeding 1 minute. So this isn't just, the off chance that, one person walked in the opposite direction or got close, or there was one aggressive person. This is a consistency value that we can see here. So if we're evaluating something like, for example, close proximity or contact tracing, we can see, okay, if people are in close proximity to each other for less than 5 or 10 seconds, then that's better than if they are in close proximity to each other for, 1 or 2 minutes. And so you can actually get these evaluations out of our simulations now. So thank you for watching, and let me know if you have any questions.
The next section is more realism. So how can you control the behavior of pedestrians and of vehicles even better than in previous versions? Let's start with pedestrians this time. Well, there are rules about distancing everywhere in the world now, and, well, we have to model this in simulations as well, of course. So what do? In this simulation, you can see the queuing behavior of pedestrians. The traditional way is at the topmost queue, the standard distancing, which kind of increases from the front of the queue to the back of the queue. And now there's a new parameter which you can enter in the queuing area to make that spacing constant, and, well, like COVID-19 appropriate spacing might be the bottom one, whereas you can also model much denser spacing for, well, from previous and hopefully future better times. Also, for pedestrians, there is a new parameter in the behavior, actually, which it's at routing decisions for the selection of stairs. You see there in the video that all those pedestrians are choosing the right stairs, even if the path obviously using the left stairs would be shorter. Why does this happen? Well, this happens because the shortest path is calculated from the center of the area where the routing decision is on to the center of the area where the route destination is, across centers of the areas which are in between where the intermediate points are. And as the center of that platform area there is on the right side, you see in the graph at the top right, the shortest distance is only using the right stairs. Now you could say, why has it done this way? Well, that's because of performance efficiency. So the calculation is of course much faster if you can do that only once per route at the start of the simulation instead for every pedestrian. But now with the quite nice improvements we have made in pedestrian simulation speed, we could offer a new method, and now you can choose to have every pedestrian calculate the shortest path for themselves when arriving on that area where the routing decision is located. And you see, well, now it works as expected. So in the routing decision, you have now the new attribute path choice method, and there you can select pedestrian position as the new option. Of course, as I said, this reduces simulation speed a little bit, but nowadays you will probably be able to live with it.
There are also options to make the behavior of vehicles more realistic. In this video, let me just play it a little bit more. You can see a red vehicle and a white vehicle overlaid. The white one uses the traditional Vissim lane change, which takes 3 seconds from the center of the origin lane to the center of the destination lane, while the red vehicle uses the new smooth lane change options. And you can see now in this video how the difference looks like.
An existing free distribution defined in Vissim in that attribute, then that distribution is used as a description of how the lateral position of the vehicle changes during that lane change. And you can optionally also have a numerical UDA named lane change duration, which then defines the total duration of the lane change. If you don't have that attribute, the default length of a lane change of 3.6 seconds is used if you have smooth lane change. And here again in a graph, the difference between the default lane change in Vissim, that would be the orange line, just a straight line from which takes about 3 seconds for the lane change, whereas the blue one is now some parameters we got from big German OEM from real life data and containing that temporal run of the lateral position over 3.6 seconds. Another option for vehicle behavior in more detail is the lane decentering behavior. There have been already attributes for driver mistakes in previous Vissim versions, but those were really like big mistakes. And now we also can model the unconscious lateral deviation from the desired lateral position, so from the center of the lane for the time being. And you will be able to set frequency and the bounds of this through user-defined attributes. In the first place, eventually those will become normal attributes of the driving behavior. And in the graph below, you can see how that works. You might know that the lateral position of the vehicle is usually defined in Vissim as a relative position, with 0 being the total right edge of the lane and 1 the left edge, and well, 0.5 is the center of the lane. And here in this case we have a lateral deviation of up to 1/10 of the lane width in both directions, so between 0.4 and 0.6. Okay, the last part of this presentation concerns features which bring you more efficiency for your projects. So you can do it in shorter time and with less manual work, more automation in a way. One thing we have now is internal signal controllers. 3 of those have already been added in Vissim 2020. This have been the pedestrian crosswalk, the 2-stage controller, and the railway crossing. And now we also have ramp metering, and all those are vehicle or pedestrian actuated signals, but you don't need any external controller for that. You don't need to do any programming, neither VAP nor script nor for a different controller. You can simply add those in Vissim and just set a few parameters. And now, and that's the center thing here, there's also an additional vertical toolbar in the network editor, which allows you to place all the objects required for these signal controllers through a few clicks in the network. So this means you don't have to individually define all the detectors and signal heads and signal groups and additional objects for those controllers, but through a guided process in the network editor, you can do this easily. And for this, there is a new short help window at the top right of the network editor window, and this includes a step-by-step instruction for those new special editor modes. So when you start one of those, you click on one of those icons in the vertical toolbar, you can always see what's the next action you have to do in the network editor. And then it also tells you about options. For example, if some keys on the keyboard modify what your mouse actions do, and you also see what the next action will be and the number of following actions in that whole process. So this is very useful if you do one of those things for the first or second time. Eventually, as you're used to this special editor mode, you can of course close it with a button in the top right, just which allows to toggle the short help off or on again if you want to check something.
The last new feature for greater efficiency is AVI recording in 2D. This has been requested for a long time, and now you can record video files in Vissim in 2D view. Well, what's the advantage of that? You can see network objects like PD stops or vehicle routes. You can use color schemes for links or link bars, as in this video on the slide here. You can see the labels as the speeds on the vehicles. And, well, it works like the recording of a 3D video. So you also have a storyboard and keyframes. You can use camera positions, which is basically zoom positions in the network and movements between those. You can use different network layouts, and you can even follow a vehicle or a pedestrian in a keyframe so that this vehicle or pedestrian is automatically kept in the middle of the video.
In addition to these bigger features I've talked about, we've also added a few smaller ones, which are also very nice and will help you a lot, and I will just show you a few of those. One is the option to hide 3D buildings, the background 3D buildings from the background maps in the 3D view. You have to right-click in the 3D view to get this editor mode, where you then can select individual of those buildings and basically toggle their visibility. So you select them with a single click. With control click, you can select additional ones. You can also drag a rectangle by with the left mouse button to select all buildings in a certain area. And very important, with the Alt key, you can make Vissim select all separate 3D objects which overlap. So if you have buildings which consist of several parts, you don't need to click each individual part separately, which is quite difficult. So you can click all those, and then finally in that checkbox they are visible, you click check that for them for being visible, or check off, leave it checked off for make them invisible, and then click the green check, and then in 3D view you won't see those unless you go back to the special mode when you see those vehicles marked with a certain color. There's one thing to add. If you have any explicit static 3D models added to your network, these switch off overlapping 3D buildings automatically. Another nice little feature, which has been requested multiple times, is persistent user-defined color schemes. So they are officially named color schemes, and this means now in the color scheme dialog there's this little button which allows you to save the currently defined color scheme under a certain name. You can also rename an existing color scheme of yours. You can override the previously defined one with the current settings, or you can delete a color scheme you have defined before. And if you just add the current selection as a new color scheme, you can enter the name, of course, for it. And all those named color schemes are saved in the layout file. So if you have the default option on to save the layout file with the IMPX file, so it's also saved when you save the IMPX file. And you can also then, if you have these color schemes in a LaYX file, you can read them additionally from that LaYX file by, well, selecting the option from File menu, read additionally, and then named color schemes. There is one hint here, which you can see then in the presentation as well if you download it later from our webpage. And there's another webpage where you can get the values for nice color ramps from, so you can well copy and paste them from there to Vissim. Together with the named color schemes, we have also changed the handling for named layouts. And well, there used to be a drop-down box here at the top left of the network editor of chart windows and of lists. And if you know how that worked, you are an expert user of Vissim, but for many new users, it was just quite not intuitive how to handle that. And now there is a button, and this button works just like the button in the named color schemes, which means you open this dialog where you can add the current settings as a named layout, or, well, you can rename a named layout, you can override it, you can delete it. And so the handling of those is much more intuitive. They are still saved in the LaX file as used, but just for selecting one of the existing ones, you click the button and then click the layout name, and, well, for adding the current one, you click the button and then you click add. This is another feature which has been requested multiple times, and that's the model archive. You know, if you want to pass a complete Vissim project to a coworker, it's hard to find all the files, to copy all those from the data directory to some other place, and not to forget anything. And now there's an option to do that automatically, and that's in the file export menu. There's now the new option to export it as a model archive, and that is then a zip file which is created in the zip archive format, and this model contains the network and all files which are referenced by the INPX file. So, for example, controller data files, and also the results database files in the results folder, but not, attention, not evaluation text files. Those are not copied automatically. Inside the zip file, there is a fixed subfolder structure, so any folder structure you might have had in your data directory is not replicated inside the model archive. But then you can simply send that model archive to your coworker, and it's sure that they can run the simulation because all required files are inside. They need to extract it with any zip compatible program, for example the Windows Explorer, and then can run the simulation. Another caveat, does not yet work for scenario management projects, so only for normal INPX files with the referenced files.